Welcome. This is the first in a series of videos on Chapter 10, Pointers. In Part 1, we will talk about pointers that reference variables that hold single values. We've called these scalars, or single-valued variables. Now let's talk about RAM, because when your program runs, all your variables are stored in RAM. And each variable is assigned a different location in the RAM. You can almost view RAM as being a post office, where each mailbox has its own address. And the location of the mailbox is called the address. And the address is a non-negative integer, but there are billions and trillions or even more of them. So for convenience, when we wrote our first programs, we never were concerned about where things were stored. We simply declared a variable, and the compiler was responsible for making sure that the variable corresponded to an address where nothing else was stored but that variable. So when we declare an integer variable called num, num is stored at RAM at some address. If you want to know what that address is, you can apply the address of operator, which is the ampersand, to see what the address is. So let's take a look. Here's this program. If we were to run this program, we'd end up with we'd have we're outputting the address, and the address comes out in a strange looking format, which is called hexadecimal. You know you have a hexadecimal number because it starts with a 0 followed by X, followed by some digits, and the digits can be letters A through F or digits 0 through 9, and this is a base 16 number. So if you ever see something that comes out, an output that looks like this, it's an address, it's not a value. Now, pointer variable is a special data type that is capable of holding only the address of some value. Okay, and once we declare a pointer variable, that variable is able to hold the address of a variable, and it is possible for you to access the variable through that pointer. Here's an example of declaring a pointer. In the past, we've said int and a variable, in which case we were declaring a variable that could hold an integer value. If we put the star in here, it says we're not creating an integer variable, but we are creating a pointer to an integer value. So the variable that we're creating is an integer pointer. You can imagine that if I wanted to point to a float value, I would have to say float star and a variable name. Putting the star in the declaration can be read two ways. It can be read to say that int pointer can hold the address of an int value, or you can use the word point, or the variable that int pointer points to has the type int. When you declare this, the spacing doesn't matter. The important thing is after the keyword int, or whatever data type, there's a star followed by an identifier. Now, here's an example of what it looks like when you declare a regular variable called num. A memory location is allocated, and the value 25 is stored there. We now declare an integer pointer, and what does that mean? This is a variable called int pointer. What does it hold? It holds an address. We denote the address by saying it's hexadecimal. And furthermore, with this statement, we are saying put into int pointer the address of num. And visually it says int pointer can have access to the memory cell that corresponds to the variable num. And if we were to print out what we have here, we will print out the address of num, and by using this special operator called a star, we can say display the value that int pointer points to. So let's pull that up. That's our second program, so that we have what you saw on the slide. And now we're going to run that. And what do we get? Let's look at the code. We first print out the value of the pointer, which comes out here, followed by the value that's being pointed to. In the visual, we saw that the variable number has the value 25, and the variable int pointer is actually pointing to that memory cell. So we can access that memory cell using the star operator. In this case, star does not mean multiply. It has a name called dereference. And the best way of thinking about that, it says follow the link. Follow the link using the address that's stored inside of this variable. Again, the value of this pointer is an address. If you follow that link, it takes you to the number 25. So let's talk about the dereferencing operator. Again, we declare a variable x, num, which we initialize at 25, and a pointer. We saw before that we can cause the pointer to point to the value of num by storing its address. And what are we going to do here though? Here it says this is an assignment statement. We have a value 44 and we need to store it someplace. Can we store it into the variable int pointer? No, because int pointer does not hold values, it holds addresses. So where do we store it? And here's how we read this. Store 44 into the memory cell that int pointer points to. And you might say, what memory cell is that? Well, we saw earlier that int pointer is pointing to the memory cell occupied by num. So in effect, are we not changing the value of num from 25 to 44? And in fact, we are. What happens if we do this? It's again an assignment statement. And we say store a value into an integer variable x. What's the value? On the right hand side we have int pointer. Int pointer, is that an integer value? No, it's an address of an integer. So we must take the address and find the value that's stored there. That is, we must dereference the pointer. That is, follow the link, and it should take me to a value. That value I want to store. Now, what's stored in this memory cell that int pointer points to? Well, 44 is stored there. So what do we expect to happen? We expect the variable x to take on the value 44. And now if we were to print these two things, we ought to be able to see that they have the values we think. So this is program 3. Let's take a look. Notice that we do a lot of stuff here. Let's look at it very quickly. We're doing what you saw in the slide, but then we're printing the values. We're going to print various values out when we run this. So let's take a look at what happens when we run it. And what do we get? We get a bunch of stuff. We get 44. Where does 44 come from? Here we're saying print the value that int pointer is pointing to, which is 44. Then we say assign value, assign the value that int pointer points to, which is 44, to the variable x. And now we're printing x, which is a 44. Next we are ready to enter a value. Whoops, 44. And here we're displaying the pointer, int pointer. And notice it's a pointer because it starts with 0x. Now we can enter a value. Let's call it 27. And what are we going to do once we enter the value? We're going to read the value where? What goes here? What do we say goes after the greater? It's got to be a variable. So by now we know it has to be an expression that takes you to a memory location. If this is a pointer, int pointer is a pointer, then if I dereference it where a variable is required, it takes me to the memory location. So this says read a value into the memory cell that int pointer is pointing to, and now we're going to display that value. Notice that when we output when we did the output up here, we got 44. When we do it down here, we have a new value, which should be the value that we just read. All right. With that, we're going to stop and resume in a subsequent